David from EZDRM to talk about key rotations, right?
Well, we're going to talk about a lot of things. We're going to talk about key management, DRM, what encryption is, what key rotation is, and a few other things. So I'm going to try to keep this very exciting and not bore you with, encryption and keys. We're going to keep this exciting about really what key management is, what a license is. So for those who don't know me, I'm David Eisenbacher, CEO and co-founder of EZDRM, but a fair amount of you do know me. So at the end of the day, when we're, we are building our video platform, and we have to care about engagement of the users. We want to make sure that we are increasing our membership as well as our subscribers. But all this is while we're also trying to ensure that our content is secure. So we're making this lovely platform, but basically we're also putting holes in it. We need to ensure that it works with current devices and older devices. And every day, more and more devices pop up. Every day, it gets harder to keep our home secure. So we're going to do a little step back, and we're going to go base what the fundamentals are. What is encryption? Well, encryption is basically just hiding what you're trying to present. Encryption's been around for, centuries. The lowest basic encryption was done by the Babylonians, where they were just doing ciphertext. They would just change letter A to letter B. And really, encryption is about that. It's about just hiding what you're trying to pass from location A to location B, so that the person who doesn't have authorization can't read. And DRM is not digital encryption management, it's digital rights management. It's about controlling the hardware. It's about how a person can actually play back that content. It's access rights, but it's not encryption rights. Now, I've been playing on this slide for a lot, and this is the smallest I can make this slide because I had a lot more rules on here and pieces. But really, I'm just trying to really explain. DRM is about the entitlements. In here, we have Apple protection levels, HDMI ports, analog ports. We have durations, how long content can be played back for, durations, how long we actually want to check in with the user to see if they're able to still play that content. But none of these DRM licenses, and it's a DRM license, so anyone who says DRM key is wrong. It's a DRM license, it's an entitlement, is really missing here. So all these policies have nothing to do with encryption. They're all the wrench. They are all a piece to basically help control your rights, but not to help control your encryption. So I'm basically calling DRM a wrench. People have, or organizations and platforms have been very accustomed to using DRM to handle encryption, to handle encryption keys, key IDs, encryption keys. And basically, with DRM handling your encryption key, it's becoming more and more inefficient. Not just because we are, basically using the transport of a DRM license, but it's really bloat. So what happens is when a license request comes in, we're saying, okay, this user is allowed to play back the content. So we have a play entitlement. And then we say, okay, yes, we have to make sure HTTP version 2.2 supported. Boom. We have to make sure HDMI is there. We have to block analog ports. And we're creating this huge entitlement list. And somewhere in the middle is actually an encryption key. But we're basically printing a book just to handle entitlements. But really, people are just trying to use printing that book to handle encryption keys. And at the end of the day, not all devices are the same. So so basically we are encrypting content with DRM, trying to use DRM to enforce encryption when there's no encryption policies in there. And then we have to support smart TVs, and we have to support laptops. We have to support handheld devices and phones and tablets. And not all these devices are equal. Some are higher end devices, and they have a much better robustness. They actually handle the DRM better. But some devices have, exposure. And because using DRM for encryption is basically using the same key structure across the board. So when we have a stream come out, it has a DRM key ID, it has encryption key, but it's the same for everyone. Key A is used by everyone watching that stream. Key B is used by everyone watching that stream. So by doing that, we are basically having holes in our ecosystem because, as we said, not every system is as secure. There are ways to harvest that key structure. DRM is great for entitlements, but key systems can be exposed. So over the years, what do? Well, if I have a single encryption key, well, maybe if I have 2 encryption keys, that's better. Or I have 3 encryption keys, that's better. Or if I have a encryption key for my audio, and an encryption key for my SD, and an encryption key for my HD, and so on, to basically try to segregate these these holes and these problems. Yes, we are lifting the bar for attackers. They have to do more work, but attackers are very good, and they also work together. So if I can find my key structure, I can publish my key structure, and that key structure works for everyone. So if I can do it once, I can do it over and over again. If I am doing multi-key, if I'm doing key rotation, if I'm doing high-frequency key rotation, it's still the same process. It's still putting an encryption key inside a DRM license, which is not the most efficient way of handling encryption. It's just making it a little bit harder. And yes, it does stop some attacks, but really it's just doing the same thing in circles. So we're in a security-minded ecosystem, we're kind of in this endless circle. We are trying to do security around our content. So we're using encryption keys, and we're passing those encryption keys via DRM licenses. And that was only, got us so far. And then they were, okay, well, now let's do multi-key. So we can separate tracks. But again, they're in a DRM license. And now we're going to do key rotation. And again, that's in a DRM license. So really, we haven't changed anything. We just try to make it harder, but we're still using the wrench. The wrench is not efficient for handling entitlements as well as encryption. So what if we could decouple? So we have content encryption keys, which is encryption. It's key IDs, it's keys. And we have a DRM license, which are 2 separate entities. So what if we could actually make them 2 separate requests? What if I could have DRM on the content that does DRM, and also encryption on content that does encryption? And by doing that, and by being able to actually decouple encryption keys versus DRM licenses, well, I can get rid of a few issues. One, I'm not bound to DRM systems that may have a security flaw. I'm not bound to the security level of DRM, which is AS, on which AS 128. I could run AS 256. I could run Cairo. So by decoupling encryption keys versus a license allows you to have a security model, which is encryption based, and an entitlement model, which is DRM based. That would be great and all, but basically, how can we do that? So there's a concept called enveloping. Enveloping at its core is taking something, and in this case, it's media, and we're putting that into a secure container. We're basically taking the letters, putting them in the envelope, and the envelope is our transport now, to where we can have a separation of church and state, to where we don't have to keep printing a book over and over again for a DRM license just to change one word in that. So the concept of enveloping allows us to accomplish that segregation between content encryption keys and DRM license. So we have to add a little marketing term to that. So we now call that position key management, because now we're truly doing keys. We're not doing licenses. There's DRM licenses and there's encryption keys. So by doing envelope key management, we can now have our content be individualized. We can offload the encryption to where it belongs, and that's on a compute layer. It could be at an edge, It could be I'm closer to that end user, but basically at a level that's actually just pure compute. It gives you the ability to do individual key structures. If we do a DRM stream, that entire stream has the same DRM key structure for everyone watching that stream. So if we hijack keys, I can publish those keys on a thread, and now everyone, Nicholas, myself, Tom, Arthur, Barry, all have the same key structure. But if we can now do the enveloping, we can now have encryption keys that allow you to actually segment. It could be encryption keys at a geo level. It could be encryption keys at a user level. So now I can have my keys be entirely different than Nicholas's keys, and therefore key sharing as well as key publishing no longer works. It allows you to have higher levels of encryption because the envelope process is outside the DRM process, so you're no longer bound to to the constraints of DRM. You can have AS256. You can have higher levels of encryption around your content to really improve your security model. And then all this, again, is an envelope. So it goes around your segment. If your segment has DRM on there, it doesn't touch the DRM. DRM can still do its entitlements. DRM still has its own encryption keys, which are separate, but the content encryption keys at the envelope level are unique. And that scales well because now by not having to reprint that book for that DRM entitlement of play values and offline values and HTTP values, just to change that encryption key, that one word in that book, you can now segregate as well as scale this independently. So because we have envelope key management, and it is that allows you to do envelope key rotation. Because we're doing content keys per user or per geo or area, I can rotate them independently of each other. My keys, if I was on a old version of Firefox and I'm seen as a higher threat, I can enforce a higher level of envelope key rotation than if I was going to a more secure domain. If I was on the latest iOS device running a main profile, I now am able to segregate my security via my trust of that end viewer. I don't have to force it across everyone. I don't have to have the infrastructure to say everyone gets a key rotation every 30 seconds, every minute, when I know that only 20% of my viewerships are really in that less secure domain. It also allows you to do a reduction of your exposure time because there's no longer shared key structures, meaning that it's not a DRM stream where everyone has the same SD key, everyone has the same audio key. I can segregate. I can turn off key structures. If I see something being compromised, I can kill one, redo it, and therefore I can do immediate action. Again, you have higher levels of of security. I can do higher versions of AAS. I can do Cairo, which is the anti-quantum algorithm. You can implement these things independent of actually changing your actual system. And the same way that you're actually doing a key rotation on DRM to where a key request comes in. Yes, you may be parsing out some token information as well as some business logic to say, hey, this is John. Well, because keys are shared in a DRM environment, sometimes it's very hard to determine if John and David are calling for the same key structure at the same time, and those keys are hijacked. So by doing the individual key structure, you now know that Tom's keys are Tom's. So why am I getting 35 requests off of different IP addresses for Tom's keys? And then, this idea of enveloping can't really happen if it doesn't only work on latest devices. And basically, it's great to have security that only works on hardware-only devices, latest support. But basically, I mean, the reality is we have to support 10-year-old TVs. We have to support older versions of Firefox. We have to support an ecosystem to maintain our viewership, as well as to grow our viewership. So having a security model that allows you to truly do security, but maintain compliance off of your devices that are current, plus a device that's going to be brand new tomorrow, is is key in all this. And I'm using the word key as a pun, but yes, it is. It's required. So, oh, I'm sorry, I lost track of my thought because I was thinking about keys. The complying with HLS, complying with Dash and devices are important. It also allows you to treat a key rotation, for what it is. Key rotation is an event. In DRM, you gotta do a period marker, or you gotta change your init, and you gotta do all these things to force everyone to do a key rotation at once. Yes, you can do some logic around kind of staggering the requests, but still, everyone's gonna need that key within a short amount of time. It's the same stream for everyone. The enveloping, by basically understanding that threat model of if I have a viewer on Firefox, may get an event to update that key at a much higher interval than a more trusted playback device that's using hardware-based DRM. It's not impossible to break hardware DRM, but it's a much higher threshold. So I may still implement a key rotation, but I don't have to force that key rotation across all my viewers at the same times. I could stagger this. I could say my key rotation at a envelope level for US or for New York or for Tom is faster or slower than for California or for other targeted users. By placing it as an event, it's able to be triggered. And triggering that event without having to change periods and boundaries, and as well as PSH boxes and and content protection headers, really allows you to control your security at that granular level. A byproduct of this, which I think is great, is it hides box structures. On left-hand side is an MP4 file. You can use a box parser and find PSH. Some people actually try not to put PSHs inside of their video manifest to make it a little bit harder. So there's no PSH inside an MPEG dash manifest or a HLS or a M308 manifest. So just have it in the init, but I can still box hash my init. I can still find my PSH information. I can still find my key IDs, and then do some brute force on harvesting. If the envelope can't be opened in the first place, then you can't get to that second layer. And these are not new concepts. We all know this because we've all been forced into it because MFA. Every time we log into a system, my PC, my AWS account, my Azure account, I'm forced to use my password, which is mine, but it's shareable in theory. But then I'm forced to use an authenticator, a multi-level or multi-factor authentication that we have been using as a security model for access into systems. It's the same principles we should start thinking about for DRM and basically as well as enveloping. So that allows you to use the full benefits of DRM, which is hardware control, and then enveloping for security control. And by that, decoupling allows you to have that scalability and as well as that unique control. Any questions?
Oof. Perhaps for you. I have a lot of questions. But first, let's try to listen to our audience.
I was wondering what the effect on CDN cacheability was of having a unique key per customer.
So, if we're doing a unique key, for basically for customer, This is really done on the edge. So basically your CDN cache doesn't change because I'm pulling from the same CDN cache. I'm just changing it in flight from CDN to viewer.
David, do you have? Oh, sorry. Who was asking?
Yeah, JP, go for it.
David, maybe it's too early, but do you have any like idea on the delivery and compute cost impact on doing these at scale, like compared to like not doing it? Because this is a lot of processing at the edge.
Yes. So it's processing. So basically what we've been doing is we've noticed that, so as opposed to individual enveloping processes calling segments independently, they call a segment once and they can re-envelope many times. So if we call segment 4 for myself, once, and then envelope for myself and you and as well as others with their own key structure, is one hit to the CDN, right? So that basically is your overall bandwidth. Because it's pure compute, it's much lighter weight. So a DRM system, because the DRM is a system is trying to make a full entitlement return, a full DRM license, that compute is much heavier than doing just pure math at the edge. Just doing a pure AES-256 job is much lighter on a compute level than running larger end servers to issue licenses. So there's a hit on the edge, but it's easier to scale these things out, and it's a much lower cost for high scalability.
Thanks.
Yeah, I see this like the issue when we had no HTTPS on every web page, and we started to have HTTPS everywhere. Like you're starting to encrypt for each connection. So it's like a similar. I see some similarities with that.
This is offloading. So we are offloading encryption to something that can do encryption very well, as opposed to a web service trying to do encryption and deliver pages and run CGI code or PHP code.
Yeah. And for example, one question is, do you have some demo with this running already?
So I kind of have a demo. I wasn't going to show a demo, but basically I will show a demo. Let's first let me load my demo. So we use super secure passwords around our demos as Qualabs knows. Give me one.
Yeah, show the demo.
You don't get to tease a demo and not show the demo, David.
It could be a video.
So function F12. So let me just do here now. Is the demo down? Is my demo working today? Just like any good thing, of course, we lose our demo right when we're trying to do this, right? Yeah, my demo's down right now.
Don't worry. We can upload it later.
Yes, we can give a demo, but in this demo, what you would see, if I just narrate it, this is DRM, so in the demo you just see black. What you'll see over here is, when in theory it works, would be all the segments loading, and we actually were doing what's called worst case scenario, where every segment, audio and video, was unique key structure, just to see how much it would impact. And pure math is fairly lightweight and is very easy to scale. And this works on my 12-year-old Tizen. So if it works there with, on a smart TV that has no memory, it can work on a lot of the newer devices.
Gotcha. And so another question, like if you're encrypting at the edge, what happened with the other part of the chain? Are you like, it is to send unencrypted content and, cache that to also then encrypt it for each user, for example?
Well,
or you see a way to do unencrypt something, maybe another, I don't know.
Well, so basically the source, which is the CDN, is probably encrypted with DRM. So therefore you have that encryption. All we're doing is a man in the middle almost, where we're adding that enveloping. Now, that enveloping could just be as small as you want, person, or It could be larger. It could be everyone in New Jersey is calling the same envelope structure. I don't need to go per user. I can for the most high valuable content, but if it's already halfway into the game and there's viewers, I can dial that down. If it's the start of the game, I can have every user, and then I can increase that radius.
Great. Any other questions for David?
Thank you.
Awesome. Thank you. I really like the way you show multi-factor and all these comparisons that you made. It's it's very, now that I see it, it's very intuitive.
It's about giving context, because enveloping, yeah, that's very boring. But no, really, what are we accomplishing at the business level?
Yeah, that's great. So thank you, David, for presenting again in our meetup. So now we are going to the other presentation today is Fabian Cancela from Qualabs. He's going to talk us about C2PA, so we can finish everything. DRM plus, I don't have the word in English.
Provenance. Yeah,
Provenance.
Which is not the same as encryption.
No.
But so I'll share my screen. Let's go back. Okay, are we there? I think we are. Okay. So hello everyone. Thank you for being here, and thank you, David, for your presentation. I'm Fabian Cancela. I'm Media Solutions Manager at Qualabs, and from the past year, Qualabs and myself have been involved in C2PA projects and studying around the topic. So I thought it could be a good idea first to continue David's presentation on C2PA down here and carry on what's happening and the challenges we are having on the video space, particularly challenges appearing in the live streaming and how C2PA is applied to live streaming and the challenges we are seeing over there. But for making you all understand this, I will need to recap a little bit on what C2PA is, the misinformation problem, C2PA crash course, very quick, how it works for video files, video on demand, then what's the difference between video on demand and live streaming regarding C2PA. If we have time, I'll do a quick demo and compare the different flavors or use cases around C2PA. So the impact of misinformation. Let me see if I can reproduce it. So every day it's easier to generate fake content.
We interrupt this program for an urgent news bulletin. Uruguay has just announced a shocking ban on mate, asado, and truco, effective immediately.
Okay, if you understood that, if you speak Spanish, if we get banned of mate, asado, barbecues, and truco, which is our card playing game, we get crazy. This is just an example, something we created today. But the jokes, removing the jokes, it's a serious problem because fake content creation speed has increased exponentially. I was creating in 10 seconds, 20 seconds mostly. The human ability to distinguish between AI-generated content and real content will continue to diminish, and it has impacts on politics, economics, news portals like BBC, Reputation, streaming platforms that allow users to upload content like YouTube or Vimeo, social networks. LinkedIn has now been working on it, TikTok or Instagram, or even your personal life. Someone created fake content about you, it would impact. So who needs to do something about it? Basically everyone, because the digital content is created in a chain. Someone is creating content, someone is capturing with their phone, someone else is editing, publishing, sharing, viewing. So in order to fight misinformation, there needs to appear solutions that work around the entire chain of custody. So that's why C2PA appeared. Initially, C2PA appeared through an Adobe, Microsoft, BBC were having different initiatives around fighting misinformation. They decided to join together and work on an open standard to establish origin and edits of an open standard to establish the origin and edits of digital content. That's called content credentials, and they help to ensure content complies with the standards as the digital ecosystem evolves. So How do they do it? Like C2PA works with manifests. So what are manifests? They have information about the origin, source, edition, and credential about the digital asset. Think of it as nutrition facts. You might have my AlphaFour here, like I have the nutrition fact, and I trust that what says there is true. Why? Because someone, an authority, has approved that, like, that's real. The same thing happens with manifests. They have information and they are signed with a certificate given to me by an authority that we all trust. Same thing like with HTTPS. So those manifests carry information about the provenance of the asset. What's provenance? It's like all this information. What happened with the asset up to the point I'm consuming it. So there's an image. Okay, they formally describe what a manifest is. It has a signature that proves it's true and claims about its assertion. And those assertions have information about the provenance. Metadata, when was it captured, by whom, where, and like actions done over the asset. If it's a picture, has it been cropped? Has it been colored corrected? Anything done to it. If it has thumbnails or ingredients, has other assets been used to create this asset I'm saying? Has it been altered by AI? It has also bindings, cryptographic hashes. So bindings goes next. So here's a visual representation of everything. You have the asset, the metadata of the asset, and then what you see in there, sorry for this picture, you cannot read it too much, but all the metadata of the provenance of that asset. And what we say when we say provenance is everything. It's the combination. So how you can attach those manifests to the asset and how you can prove that they are correct. You have hard bindings and soft bindings. Hard bindings are when you cryptographically hash using the bytes of the content, like you attach the manifest to the asset, and you can say, this manifest belongs to this asset. And also, this asset content is valid. And you do it like with cryptographic hashes using the raw bits of the asset. Soft bindings is other ways of doing it. Watermarking and fingerprinting are examples that are being worked in C2PA. They can work for different purposes, and it doesn't use the raw bits of the asset, but the content itself. It can help, for example, if an attacker strips or removes the manifest information, you can use the watermark, for example, to know that in some database or somewhere else, you can recover the manifest or the provenance information with a watermark that may be invisible to the user, but has information where to find it. This is just showing like how different ways of doing it. I'm going to talk mostly about hard bindings. But this is like different things to do. The standard says like soft bindings are optional, but if you want to increase your trust levels, you can include them for extra levels of trust. Very quickly here, you can play around with this type. Here's an image, so you can see it. This is an image that has ingredients. Ingredients meaning other assets, other images have been used to create this image, and you can see all the provenance of this image. If you want to test around, there are different types of PDF, audio, text, different file formats that you can play around in that site. How do I verify what I'm seeing? So the process of verifying what I'm seeing is I receive the asset, the picture, for example, and I will see that manifest information that will be embedded in the picture. I check if the signature is correct and hasn't expired. If the signature is correct and it hasn't expired, I will start reading all the assertions, all the provenance information about the picture and start validating. And if an ingredient, let's say another picture has been used to create that one, I will continue the chain until I have validated the entire history of the asset. What happens about, like, that was using an asset, but what happens in video? The standard defines how to do it around the base media file format. BMFF files are commonly used for MP4, so the typical video format we use in streaming. And they state that in order to embed that manifest information into the asset, we use the UUID box. This is more for the curious people that want to know where the information is going to be. So they will be in the UUID box and has to be placed after the FTYP box and before the MDAT mob boxes. So in that place within the BMFF, the manifest will be placed. But that's not that easy. Like we have one asset MP4, but when we start streaming and video on demand, we start transcoding. We have one asset convert into now multiple files. And we need to prove that the provenance is correct now in multiple files simultaneously. How do you know that that segment wasn't intervened? Like that someone stripped one of the files. How do you validate that what you're seeing is part of the VOD you have been watching so far? An analogy that David used to explain me, and it was very helpful, is how do you know that if that deck is part of the deck of cards? If that card is part of the deck. Sorry. So the good thing is that when we're signing, we know the entire asset information beforehand, and we need to find a way to assure that it chunks belongs to the original asset. No, like assuring no reorder, no elimination, no manipulation. But we have time. I'm going to go quickly around this, but C2PA for VOD established that Berkeley tree algorithm works. Basically, you will, for each chunk, you will calculate based on the MDAT mob boxes, or maybe other ones too. You can decide which ones. Calculate a hash for each of them. And within the manifest, you will give enough information to the consumer so that they can recalculate this tree upwards. Let's say we are in chunk 1. You will receive all the ones in orange. So you can start calculating up to the root and verify that the entire tree structure is correct. Sorry, that segment you're watching belongs to that tree. This serves the purpose for VOD because you will know that what you're watching belongs to that asset. Despite being chunked, you still know that no one give you another one in that place. It serves for reorder, elimination, etc. In this presentation, I don't want to focus too much on VOD. You can go and read about it. Has already been is part of the standard. But what's not part of the standard yet is how to solve it for live. In that, there's a few differences. It's not the same as VOD because we don't know the entire asset beforehand. We don't know for how long the stream is going to run, potentially indefinitely. I'm using that example of the lo-fi girl in YouTube. It has been running for more than 8 years, 7 years, I don't know, around that. The consumer is subject to switching context, like ad insertion, A/B switching, ABR renditions, and the user can join at any point in time to that live stream. So the provenance has to be valid, covering these conditions. So some of the requirements that you can get based on those conditions is that for a live stream, the way you do it, it must not increase latency because this would affect the consumer experience. It must not decrease video quality. For example, in order to validate, you need to download many chunks or many previous chunks or whatever information that can cause you to reduce to the lower ABR rendition, and that's not desired. And over time, it cannot increase latency. Like the example of the lo-fi girl. If we spend 5 years, the algorithm has to cover for those scenarios too. Also, it has the ability to switch context and eventually be converted to VOD afterwards. It's not part of any standard yet how to solve this. So what I'm going to do now is show you different ways that we could solve this and show you there are different ways of doing it. Probably the industry will go into having more than one algorithm, and each one will serve different purposes. But this will more illustrative on show you different paths we could take. So one idea is chaining. So definitely something that only depends on the path sounds reasonable. How chaining could work here? We define an anchor point. An anchor point could be every 10 segments, 20 segments. We call that an anchor point. And what we'll start doing is next segment will be cryptographically linked to the previous segment. Correct. Thank you, Ben, for the. I saw you doing like, okay. That's exactly what I mean. So we start moving onwards on the stream, and everything, the chain will be covered. But if we join later in the stream, in order to know we are in the right place, the right time, we will need to validate up to the anchor point. And that can be consumed in CPU or like, it can increase, making the player download many chunks, so can decrease quality, and it can also be intensive for the player. Another idea. So I wanted to represent three, so you keep thinking which one sounds best for you. Anchor point. Instead of chaining, as I told you before, we can also define same way anchor points, but instead of chaining one with the past one, we can define every 10 segments, but all of them are cryptographically linked with the anchor point. This helps in a way because, for example, if a player joins in segment 3, it only needs to download and validate anchors of segment, like the past anchor point. But how do you know they are in the right place? Okay, so one idea is to define like a key per anchor. The key can be a function of the content ID or something that doesn't like gets duplicated for different content, and maybe an initialization vector. And that initialization vector can be a function of the segment number and stream ID. And segment 3 will have an initialization vector that is also function of the anchor point and the position relative to it. Let's say +1, +2, +3. So the ID of segment 3 is the ID of the anchor point +3. Very simple. It can be something like that. And that way you know that it's in the right place. One of the constraints here is that this is subject to, if someone eliminates segment 2, you wouldn't notice because the only link is with the anchor. Finally, third approach. Every decoder in live streaming will need the init segment. So that sounds reasonable to think like, if we always need the init segment to start the stream at any point in time, we connect in segment 3, let's say, I'll need to download the init segment. So maybe the init segment can carry some of the C2PA information, and we can cryptographically link it to that init segment. There we can still use the same mechanism of something that determines the position at where it should be, for example, a sequence number. And this could also serve as a different way of doing it. So instead of depending on a segment, you always point to the init segment. You can add some type of algorithm like key rotation in the init segment. That would add some complexity on the server side, but it could work. So here I'm presenting 3 different alternatives. They have them different pros and cons. Chaining, like every segment is cryptographically linked to the past one. That's good, but startup validation delay can start to increase if the chain is too big. Can be heavier on compute, and switching between renditions can be a problem. I didn't have too much time here, but I started thinking of these different solutions. How do you handle A/B switching, ABR? How do you know that the provenance is not broken? Or do you need much compute when you switch between conditions? The anchor point is faster to join, but you don't have the full history. If someone eliminates a segment, you don't notice it because you always go back to the past anchor point, not to the past segment. And the init segment is good in the way that it follows streaming protocols. The decoder always have to download that init segment. You're like making use of current behaviors of the player, but there's a single point of failure if someone corrupts that init segment. Although you can protect against it with key rotation, it's still something you need to make sure how you do it. So, one thing we have been working with this DRM is on one of these ideas. So I'm going to share very quickly. I know it's a lot of information, but hopefully give you like an idea of what we're working on, what C2PA is. So here what we are doing, it's a player, it's the -AS player with C2PA credentials, and we are validating each segment and their C2PA information that's being carried in the manifest. So here, okay, here what you can see is one anchor point is reset after 9 segments, and we're validating each of them. So the chain, this is using the chain solution. So each segment is linked to the previous segment, and every 9 segment we're defining a new anchor point. So, yeah. So here what you will see is basically, and each time a segment is downloaded, I will be able to see all the assertions, all the manifest information, all the signature, all the details that give me. It's not as cool in a viewer as seeing the entire history and ingredients, but we can see all the segments, all the hashes, all the details of what has happened with this content beforehand. I can see the credentials. I can see it has been using a test certificate, which is the one given by default by the open source tool. Now going back to the presentation, what I think is different type of events will have different type of provenance. They need like different use cases. And sorry, I will repeat that. Different use cases will require different levels of provenance. High churn events like a football match, a very important football match, may be different than a 24/7 channel than a mobile IRL citizen live stream or an emergency broadcast. What I believe is potentially we will design our provenance the same way we design our ABO ladders. We will pick the right profile that best satisfies the domain constraints of a specific live workflow, such as the audit depth, startup time requirements, device budget, ad insertion solution, etc. So I think that's mostly it. The C2PA standard is going to move forward, probably having more than one approach, depending on the use case. I cannot confirm, but it seems like it'll probably go in that direction. If you're interested in sharing these kind of discussions, here's like the membership to C2PA, the public files I showed you during the presentation, and a link to the GitHub C2PA Rust toolkit as we have been using for our demos. Any question? And thank you.
Excellent. Thanks, Fabi. Questions from the audience?
Go ahead, Arthur. You were clapping. I thought you were raising your hand.
Quick question, Fabi. In terms of use cases, why I can see it for news or brand safety, things like that. Why would you want to put C2PA for a football match or something like that?
Well, one use case can be let's say you're adding overlays, you're adding ads, like maybe not the content, but probably when you jump into an ad, there's potential for some attacks over there. So that's one example. In the football match stream itself, that's a good question. But one thing I've seen is maybe not the biggest like NFL matches, but each time more and more football matches have been streaming on lower leagues. For example, last summer in Colombia, there was a match during Christmas in Twitch TV that had 300K viewers, but they were only streaming like with a very simple solution. So that was an example where I thought it could be attacked, let's say.
Mm-hmm. Mm-hmm. Also, one thing, just to mention something from previous experience we have, in internet, this maybe you do not agree, but again, thinking about when we only had HTTP and migrated to everything HTTPS, like the user get used to, okay, this is HTTPS, it's green on my browser, everything is good. And then sometimes maybe you're just going to any web page, but when you see like there is a red over there, you say, oh, now that, imagine a future where C2PA is more widespread, maybe my grandmother would say, hey, maybe, what is this that is not green, So maybe we could have that kind of situation that we already live that in HTTP and HTTPS migration world. Just random thought about this.
Well, that makes sense for longevity to getting to that point. In the beginning, though, it's going to be the uphill battle of how do you convince people that it's needed, and so you can get to that critical mass where it becomes normal.
I agree. Like, I don't think one slide I had to basically remove because of the time, that C2PA goals is that it's opt-in. It's not going to be enforced for everyone, but it's something you can opt to add to your content in case it's needed. So that's a good question that you raised, and maybe they don't need it. And each industry, each vertical that uses media will have to decide why and whether they need it. But that it's needed for the industry, I think it's pretty clear. And they will have to discern if it's valuable for their business to add it or not. Go ahead, Arthur.
Yeah, I realized, and you might correct me, I'm not an expert in that, but I thought interesting use case could be for the government, because you want to make sure that everything they share is protected.
Yep.
And original.
I agree with you. Thank you.
Like some security defense ministry and go and sell it there. Yeah.
I think we're on time. If there are no further questions, we will free you.
Yeah.
You're free.
Now also like mixing both talks, talking about, I know if we are going to package something in the edge, and if we are going also to envelop and all this, like I see connection where maybe C2PA plus DRM will go together some way. So great.
Bravo.
Thank you everyone for being here. As always, we're going to upload the recordings in our YouTube channel so you can catch up if anything or share the conversations with anyone. So thank you once more to be here and see you in the next one.